Welcome everyone to geometry. We want to take a look today at section 15. So we'll start by just giving a little bit of an introduction, taking a look at a couple theorems, and then pause and continue on in another video. So we're moving on to parallels in Euclidean geometry. And I mistakenly said in a previous section that where we were talking about parallels and triangles in neutral geometry, that we could think of it as Euclidean geometry. And while that's not entirely false, it's maybe not quite as true as I would have liked it to be. Everything that we've talked about prior to this is certainly true in Euclidean geometry, but what we end up with are actually generic enough axioms, theorems, corollaries, and the like to have still several geometries that result. So we don't get Euclidean geometry until we start actually talking about parallels. And what we would like is we would like to have, given a line and a point P, that there is exactly one parallel through P, right, that is parallel to some line L. And unfortunately, with all of the theorems and axioms and postulates that we have on hand so far, we cannot actually prove this. It's impossible. So what we do, right, well, I suppose, we said that there exists one, but we said that there exists at least one. We didn't say exactly one. So we want it to be exactly one. And that's what we can't prove. We cannot prove that there's exactly one. There could be 2, there could be 10, we don't know. And we cannot prove it. So we call it an axiom. We let it be a postulate, right? We're going to say that it must be true. And as soon as we do that, we enter Euclidean geometry. That's why it's called the Euclidean parallel postulate. Given a line L and a point P not on that line, as we have above, there is exactly one line that is parallel to L and that contains P. So now that we have this, we can do quite a bit. We get the converse of the theorems that we looked at in the previous sections, along with just the usual things that we would have with Euclidean geometry. So we'll take a look at some of those things in this section. All right, so first, the transversal parallels theorem. So if a line intersects one of 2 parallel lines, so let's say we have line L and line M, then if it crosses one of them, then it has to cross the other. So if a line intersects one of 2 parallels, then it intersects the other. Excellent. So let's prove this. Well, let's do that by assuming that this transversal T passes through L, okay, but does not pass through M. So assume that we have 2 lines, L and M, which are parallel, and let T be a distinct line, from L, intersect L at some point P. Excellent. Since L and M are parallel, since L and M are parallel, P is not on M. Of course it's not. So let's suppose T does not intersect M. So if T does not intersect M, then we have a pair of parallel lines, right? A pair of non-intersecting lines, T and M, which means that T and M are parallel, and T is a line parallel to M passing through P. Then T is a parallel to M passing through P, and let's see here, there's only one line that is parallel to M that passes through P, and that is L. So, right, that's what we get from the Euclidean parallel postulate. So T is a parallel to M passing through P, and well, actually, let's just leave it at that. Let's see if I can get rid of that. Yep. But there's only one parallel through P. Well, I suppose there is only one line through P parallel to M. But what does that tell us? That tells us that the line L and the line P are not distinct. L and T are the same line. But that is a contradiction. Thus, T must also pass through M. There we go. Excellent. And that's all that we needed there. So let's take a look at our next theorem, transitivity of parallels. If two lines L and M are parallel to the same line T, then L and M are also parallel to one another. So two distinct lines parallel to the same line are parallel. Excellent. All right. So the next video, which will be a little bit longer, is going to talk about the converse of the theorems that we took a look at in the previous section. So we'll leave this here for now, and I will see you guys again in just a little while.